so this is our second lesson video for section 10.3. So in the first lesson video, we focused on percent composition. In the second lesson video, we are going to focus on something called empirical formula. So the molecular formula is the actual formula for a molecular compound. It contains the actual number of each type of atom. The empirical formula, however, which is what I'm going to show you how to calculate today, is the lowest whole number ratio of atoms in a molecular compound. So it might not necessarily be the actual, it's the lowest ratio. So for example, glucose is C6H12O6. That's the molecular formula. I'll abbreviate that NO. But 6, 12, and 6 are not the lowest ratio. I can reduce them. If I reduce them, it becomes CH2O. Since this is the reduced or lowest ratio form, this is the empirical formula. Now, molecular formula and empirical formula can be different. They can be the same. In reality, a molecule of glucose has 6 carbons, 12 hydrogens, and 6 oxygens. It doesn't have 1, 2, and 1. This is just the reduced form of it. But like I said, sometimes they're the same. So like a molecular formula P4O10, 4 and 10 can be reduced to P2O5. So this is the actual formula of the molecule. This is the reduced empirical formula. But like I said, sometimes they're the same. Like H2O water, that's the real molecular formula. We can't reduce a 2 and a 1, so the empirical formula of water is also H2O. So sometimes they're the same, sometimes they're different. So let's look at how to calculate it. So sometimes the empirical formula and molecular formula is the same, like I said, for example, water, H2O. But a lot of times they're not. So there are steps to calculate the empirical formula. So I'm going to kind of abbreviate our steps and put them over here so I don't have to keep coming back to this slide. So step 1 is change percent to grams. Step 2 is we're going to convert grams to moles. To do that, we're going to use our molar mass. And then step 3 is divide by the smallest. Now, I know right now none of those make any sense because we haven't actually started one. Okay, so these are the rules that we're going to follow, so let's look at what's going on. So it says calculate the empirical formula for a compound that is 67.6% mercury, 10.8% sulfur, and 21.6% oxygen. All right, so the important thing is you have to understand what is our answer going to look like. Is it going to be a number? Is it going to be a formula? Well, we're calculating empirical formula. So what that means is I know it's going to have Hg, I know it's going to have S, and I know it's going to have O. What I'm really looking for is what are the subscripts. So those are the numbers we're trying to figure out. Is it Hg2S3O7? Is it HgSO2? You know, what are the subscripts? That's what we're looking for. All right, so step 1 says change percent to grams. So if you notice, I gave you 3 percentages. How can we change percent to grams? Well, what we do is we make an assumption. We assume that we have a 100-gram sample of this compound. If we have a 100-gram sample of the compound, then these percentages are our actual gram values. So step 1 is the easiest. You just take away the percent sign and you write grams instead. All right, so 67.6% of mercury just becomes 67.6 grams of mercury. 10.8% sulfur just becomes 10.8 grams of sulfur, and 21.6% oxygen becomes 21.6 I might have just said 21.6 grams of oxygen. All right, and so again, the reason that we can do this is we are assuming there is a 100-gram sample. All right, so we did step 1, check. Step 2 is change grams to moles. So to do this, we have to use the molar mass. So remember how we said 1 mole equals molar mass? So I pull my masses from the periodic table. All right, so we know 1 mole equals molar mass. So I'm going to start with mercury. So golden rule says if grams of mercury is on top, grams of mercury goes on bottom. How many grams? Well, look at the periodic table. It's like 200.59. So I'm going to round that to 201 grams. So what does 201 grams of mercury equal? It equals 1 mole. So what you'll do is you just divide each one by its mass on the periodic table. All right, so we do 67.6 divided by 201 because, of course, that is one on top, one on bottom, and we get 0.34 moles of mercury. So see, I changed it from grams to moles. And we just do the same thing. All right, so sulfur, grams of sulfur is on top, so grams of sulfur goes on bottom. We find the molar mass on the periodic table. Molar mass of sulfur is about 32. We're just pulling the atomic masses off the periodic table. Hopefully you have a periodic table up. All right, and then the molar mass equals 1 mole of sulfur. So grams cancel. So 10.8 divided by 32 gives me about 0.34. All right, and so then last one I do oxygen. So grams of oxygen is on top, so grams of oxygen goes on bottom. How many grams? Well, oxygen's about 16 on the periodic table in its mass, and 16 equals 1 mole. So grams cancel, I'm left with moles, and I get about 1.35. All right, so we successfully changed percent to grams by just changing the percent sign to a gram, and we converted grams to moles using our molar masses. Now, the problem is these are my subscripts, but have you ever seen a formula that says Hg 0.34, S 0.34, O 1.35? No. All right, so what we do is we assume, now this assumption is sometimes going to work, it's sometimes not. I'm going to show you when it doesn't work in a few minutes. We're going to assume that the lowest subscript must be a 1, because obviously you can't get less than 1. So to do that, we find the smallest number. In this case, we have 2 of the smallest numbers, 0.34, and we divide each answer by that smallest number. So see, what happens is if I take 0.34 and divide it by itself, I'm going to get 1. I'm also going to do the same thing here. And I'm going to get 1. And then I'm going to divide the last one. So see, I found my smallest, which is 0.34, and I divide each one by the smallest number. So that's step 3. And when I divide 1.35 by 0.34, I get 4. Now, you might not get perfect whole numbers on this step, but you should get really close, like getting 3.985. That we can round to 4. Or getting like 1.04, that can round to 1. You should be getting incredibly close to whole numbers here. And so now these whole numbers are my subscripts. It's 1, 1, and 4. So we know 1s are understood. So my empirical formula is HgSO4, just like that. Our empirical formula, it is a pattern of steps that you follow. You just have to practice them, but it gets easier as you practice each step. All right, so whoops, oh gosh, throwing my marker here. So let's look at a couple more. And when you see the first one, it's kind of overwhelming. But once you get in there and start practicing it yourself, you realize, oh, you just follow the steps. All right, so we'll look at the top one together, and then I want you to try the bottom one. So in the top one, we have 94.1% oxygen and 5.9% hydrogen. So I know I'm going to have O with a subscript, H with a subscript. I have to figure out what they are. All right, so remember, first step is change percent to grams. That is not a math problem. You just take away the percent and change it to grams because we're going to assume that we have a 100-gram sample. Okay, so all I did was take my numbers and get rid of the percentage and do grams. Next step is I'm going to convert grams to moles using the molar mass. All right, so remember, we know 1 mole equals molar mass. So for oxygen, grams of oxygen goes on bottom. I'll look at the periodic table, oxygen is 16. That equals 1 mole of oxygen. Remember, molar mass always equals 1 mole. So I do 94.1 divided by 16 grams, and that gives me 5.88 moles of oxygen. So I changed from grams to moles for oxygen. Now I'm going to do the same thing for hydrogen. Grams of hydrogen goes on bottom, so I'll look at the periodic table. Hydrogen is 1, and that equals 1 mole of hydrogen. So of course I end up with 5.9 moles for hydrogen. So So I did step 1, I changed percent to grams. I did step 2, I converted grams to moles using the molar mass from the periodic table. Step 3 is divide by the smallest. So obviously these numbers are practically the same, but I will say that my smallest is 5.88. So this is going to give me 1, and this is practically going to give me 1. Remember, I told you a small amount of rounding here is okay. All right, so that means both subscripts are 1, so that means my empirical formula is OH. And that's it. All right, so you try this bottom one. All right, just give it your best shot. Just follow the 3 steps. If you can do this one, it makes the next ones we look at a little bit easier. All right, if you need to go back and rewatch the previous 2 first, do that. All right, I'm going to assume you've tried it. All right, so the first step is change percent to grams. So remember, all I'm doing is I am taking away the percent sign and I'm writing grams. So I know my formula is going to be C something, H something, N something. All right, so I have 62.1 grams of carbon. I have 13.8 grams of hydrogen, and I have 24.1 grams of nitrogen. If all else fails, you should be able to do step 1. All right, step 2 is convert from grams to moles using molar mass. So I look at the periodic table. Carbon is 12 grams. I put the grams on bottom, so grams will cancel. That equals 1 mole for carbon. So carbon is, let me find it, 5.175 moles of carbon. All right, hydrogen, grams goes on bottom, so it'll cancel, and it's 1 on the periodic table. And that, of course, equals 1 mole. So that's going to give me 13.8 moles for hydrogen. And then the last one is nitrogen. So grams is going to go on bottom. I'm just following my golden rule here. And nitrogen is about 14 grams on the periodic table. That equals 1 mole. So when I do 24.1 divided by 14, I get 1.72 moles of nitrogen. All right, so we convert it to moles. So remember, our third step, the reason we divide by the smallest is we are assuming the lowest subscript is a 1. All right, so which one's my smallest? 1.72 is. So I'm going to take it and divide each one by 1.72. All right, so when I divide my top one by 1.72, I'm going to get approximately 3. When I divide 13.8 divided by 7.2, I'm going to get approximately 8. And when I divide 1.72 by 1.72, I obviously get 1. All right, so that means my subscripts are a 3, an 8, and a 1, or it's C3H8N. All right, so hopefully you got that one right. If you got that one right, you should feel accomplished. These are tricky because it's a lot of steps. All right, now, what we're going to look at next is this assumption that the lowest one is a 1. Does every formula have to have the lowest subscript as a 1? No. What about P2O5? That's an empirical formula. A 2 and a 5 can't be reduced, but the lowest subscript is not a 1. So sometimes our third assumption falls apart, and then there is a fourth step. Sometimes. So I'm going to start, because we only use it sometimes. All right, so let's look at what that looks like. I know you're probably thinking, oh my gosh, how can these get any longer? Well, they do. Sometimes. It just depends. All right, so let's look at one where we need our fourth assumption real quick. So after step 3, you should get whole numbers, or very close to whole numbers, that can be used as subscripts. However, sometimes you will get a number that ends in 0.5 or 0.3. Do not round these numbers. Like if you get 2.5, you don't round it up to 3. What that means is our assumption that the lowest subscript is a 1 was wrong. So if something ends in a 0.5, you multiply all answers by 2, even the other ones that don't end in a 0.5. Because 0.5 is a half. How do we get rid of a half? We multiply by 2. All right, 0.3 or 0.33 means we have a third. So how do you get rid of a third? You multiply all the answers by 3. Okay, and that's the problem that people run into, is they'll see the 0.5 and they'll multiply that answer by 2, but then they won't do it for the other ones. So let's see what this looks like. All right, so for step 4 over here, I'm just going to say if you have 0.5, multiply by 2, If you have 0.3, multiply by 3. Okay, you might have 0.33 repeating depending on how well you rounded your other answers. Alright, so it says a compound is analyzed and found to contain 25.9% nitrogen and 74.1% oxygen. What is the empirical formula of the compound? So we know that we have N something, O something. Alright, so is it like NO3? Is it N2O7? What is the empirical formula? So, first step is percent to grams. So remember, that all you do is take the percentage and change it to grams because we are assuming that we have 100 grams of our substance. Alright, so step 2 is I am going to convert grams to moles using the molar mass. Alright, so grams of nitrogen is on top, so grams of nitrogen goes on bottom. I find that it has a mass of 14 on the periodic table, and that equals 1 mole of nitrogen. So once you do 25.9 divided by 14, you should get 1.85 moles. Alright, next one, oxygen. Grams of oxygen is on top, so grams of oxygen goes on bottom. I find oxygen on the periodic table. Its mass is about 16, and that is the mass of 1 mole of oxygen. So once I divide my oxygen, I get 4.60. Now, a lot of you stop here and you say, wait a minute, this isn't a 0.3, this isn't a 0.5, what do I do? Well, you still have to do step 3. Like a lot of you all of a sudden, once I teach you this part, you just skip over step 3. You still have to do step 3 and divide by the smallest first. Alright, so what's my smallest? Is 1.85. So I'm going to divide each of them by the 1.85. So when I do that, this obviously gives me 1. But this one, when I divide, gives me 2.5. Now, I know that you are tempted to just round that to 3. Why wouldn't we just round it to 3? But remember, this means that our assumption that the lowest subscript is going to be 1 is wrong. So what do I do when I have a 0.5? I multiply by 2. But I do it for all my answers, not just the one with the 0.5. So I'm going to multiply this one by 2, so it becomes 2. I'm going to multiply this one by 2, so it becomes 5. So my answer would be N2O5. So see, notice that neither subscript is a 1. That's why we had to do that step 4, because neither of the subscripts were a 1, and this can't be reduced any further. Alright, so I'm going to give you one to try. Even if you can only get through to step 3, that's still a good amount of work that you got done. Okay, but I'll go ahead and tell you the next one is also going to have that step 4. So just be prepared. And remember, once one of the answers ends in a 0.5 or 0.3, you have to multiply all the answers by a number. Alright, so try this one. Like I said, even if you get stuck and you can only get to step 3, that's still an accomplishment for right now. You've just learned how to do this. Alright, I'm going to assume you've already tried it. So it says, determine the empirical formula for a compound that's 50.7% carbon, 4.2% hydrogen, and 45.1% oxygen. So we know we're going to have C something, H something, O something. So we need to figure out what our subscripts are. Alright, so remember, step 1 is change percent to grams. That's our easy step because all we do is take the percent sign away and put grams. So we have 50.7 grams of carbon, 4.2 grams of hydrogen, and 45.1 grams of oxygen. Alright, step 2 is convert grams to moles using the molar mass. So let's start with carbon. Grams of carbon's on top, so grams of carbon goes on bottom. Carbon on the periodic table is 12, and that equals 1 mole of carbon. Okay, and remember, 12 is just the molar mass that we're pulling off of the periodic table, the atomic mass underneath the symbol. So 50.7 divided by 12 is 4.225 moles of carbon. Alright, so next is hydrogen. Grams of hydrogen goes on bottom, so it will cancel. We're just following golden rule. So hydrogen 1 on the periodic table. That, of course, equals 1 mole. So hydrogen is 4.2. Alright, our last one's oxygen. So we're following golden rule. Grams of oxygen goes on bottom. Oxygen has a mass of 16 on the periodic table, once you round. And that equals 1 mole of oxygen. So grams cancel. And so when you do 45.1 divided by 16, you get about 2.82 moles for oxygen. All right, so again, don't stop here and start trying to figure out what to do with your decimals. You haven't done step 3 yet. So step 3 says divide by the smallest. So what's the smallest? The 2.82. So I'm going to divide each one by 2.82. All right, so when I do that, my top one ends up being 1.5. Don't round that to 2, okay? I know, it's been ingrained in you. 5 and up rounds up. I mean, I even told you that when we were doing significant figures. Okay, but in this case, don't round. When you divide this one, you're also going to get 1.5. And when you divide this one, clearly you're just going to get 1. All right, so we have a 0.5. How do we remedy that? That means our lowest, when we assumed our lowest subscript was a 1, it wasn't. So if I have a 0.5, I need to multiply by 2, but I need to do it to all of them. So I multiply this by 2, and I get 3 moles. I multiply this by 2, and I get 3 moles. I multiply this one by 2, even though it didn't have a 0.5, because I have 2 moles. So my subscripts become a 3, a 3, and a 2, or it becomes C3, H3O2. So if you have that one right, you are super awesome. Because this is the longest type of problem in this chapter. Okay, so don't worry, it's not going to get any longer, because in the next lesson video, we're going to learn the last type, but it's actually much shorter, if you can imagine. All right, so hopefully empirical formula isn't too bad. You're just following our 3, sometimes 4 steps. Just don't forget, you have to do step 3 before you consider if you need step 4 or not.